As we begin this unit, please note that this is chapter 3 in our book and not chapter 8, like some of your notes may indicate. We are going to talk about motion and force in this lesson. Physics is the study of motion. That's the basic definition. You should highlight that. And the definition of motion is a movement of an object from one place to another, which should also be highlighted. Goes over the definition of motion again, and then goes into the definition of speed. This is the distance an object moves in a certain amount of time, such as 55 miles per hour or 30 meters per second as illustrated. If you need to pause the video at any time to write things down, definitely do so. The formula for speed is V equals D divided by T, where V stands for speed or velocity, which we'll touch on velocity in a second, D equals distance, and T equals time. This is the speed/velocity triangle. I would pause the video and write this in your notes somewhere, labeling distance in meters, normally, time in seconds, normally, and velocity, which stands for speed or velocity, should be labeled in meters per second. The difference between speed and velocity is that velocity describes both speed and direction. If you think back to speed, that was just a number and a label. This will now be a number, a label, such as 55 miles per hour, but now it's going to tell you a direction, such as south or northwest, something like that. So a couple of examples that you have is you have north at 55 miles per hour or 2.0 kilometers per hour southeast. If you didn't have the directions, they would just be speed. But since you have the north and the southeast, those are considered velocities. Uses the exact same formula, so it doesn't get super crazy. V equals distance divided by time. So an example problem, what is the speed of a squirrel that traveled 63 meters in 8 seconds? You will cover up the V on your triangle to give you V equals D divided by T. You would take the distance of 63 meters divided by the time of 8 seconds, and it should give you 7.88 meters per second for this speedy little squirrel. Another example that asks you to look for something else different says, what is the distance traveled by a spaceship in 5 hours with a velocity of 12,000 miles per hour? You would cover up the D, which would leave velocity times time. You would take 12,000 miles per hour times 5 hours, which would give you 60,000 miles that the spaceship would travel in 5 hours. What is the speed of a truck that traveled 42 miles in 4 hours? I want you to go ahead and try and fill in the blanks before I do. If you cover up the V, that would give you D divided by T. Put the 42 in for the D, 4 in for T. That gives you 42 divided by 4, which comes out to 10.5 miles per hour for the speed of the truck. How far did Homer go if he traveled 36 miles per hour in 2 hours? How far means you're looking for distance. You would cover up the D, and that gives you velocity times time. So you would plug in 36 miles per hour for the V and multiply that times 2 hours. And that would give you 72 miles that he would have traveled. How far in meters did a runner go if she ran at a rate of 2 kilometers per hour for 4 hours? Again, how far is distance? Cover up the D, and that will give you velocity times time. So you would take 2 kilometers per hour times 4 hours, and that would give you 8 kilometers, but it asks you for meters, so you have to convert. So to go from kilometers to meters, you are going to hop 3 to the right, and that will give you 8,000 meters. How much time does it take a car to go 6 kilometers if its speed is 2 meters per second? We're looking for time, which is a different one than we've done so far. Cover up the t, and you would do distance divided by velocity. Take 6 kilometers divided by 2 meters per second, but you should see a problem there because you cannot take kilometers divided by meters. They have to be in the same unit. So I would take the 6 kilometers and change it to 6,000 meters. Same process you just did. You would take kilometers, hop 3 to the right to get to your meters to give you 6,000 meters. Then it would be 6,000 meters divided by 2 meters per second to give you 3,000 seconds. The other thing we're going to talk about in this lesson is momentum. This is kind of how much oomph something has as it is moving. P is going to stand for momentum, and I would pause the video and get this in your notes before you listen to the labels. P stands for momentum. That's going to be measured in kilograms times meters per second, and I will show you how to write that on the next slide. The M is going to stand for mass, and that will be in kilograms. And the V is going to stand for velocity, and that's going to be in meters per second. This depends on both objects, the object's velocity and its mass. And it shows you the exact same formula that we just drew in the triangle. P equals M times V. Mass times velocity. There's the metric unit for momentum, kilograms times meters per second. And that all that is taking the 2 units and multiplying them together like you are going to be the numbers. The mass must always be in kilograms. If it's not, you have to change it to kilograms, but I think all of the problems I give you, it's already in kilograms, but just double check that. So an example, what is the momentum of an athlete with a mass of 73 kilograms running at a speed of 1.5 meters per second? So you have P, which is momentum, equals M times V. You would take the mass of 73 kilograms and multiply it times 1.5 meters per second. 73 times 1.5 is going to give you 109.5 kilograms times meters per second for the momentum. Now what you will do is I've uploaded a practice problem sheet. Please put your 3 columns on your paper, go through and try these using the triangles that I've given you. The 3 columns, just as a reminder, are formula, work, and answer with units. Give the extra credit problems a whirl down at the bottom, and then make sure you convert some units on the 2 blue highlighted problems. So if you have any questions, you can email me. I'm hoping to be back in the classroom by Thursday, and we'll review all this and go over the math once I can be back at school. Have a good day.